Find the eigenvalues and eigenvectors of a matrix. Square matrix is given. A is equal to 1 1 3 1 5 1 3 1 1. Okay, find the eigenvalues and eigenvectors. Now first, the characteristic equation. Modulus or determinant a minus lambda I equal to 0. So write in a form. So a minus lambda I, take diagonally minus lambda minus 1 minus lambda 1 3, the first row. Second is 1 5 minus lambda 1. Third row 3 1 1 minus lambda. Okay, this is a determinant equal to 0. Now on expanding this one, therefore 1 minus lambda multiplication these elements, 5 minus lambda into 1 minus lambda minus 1 into 1 is 1. The second element, take minus sign, plus minus plus, minus 1, these elements multiplication. So multiplication 1 minus lambda, then minus 3, then plus minus plus, then plus 3, and these multiplication 1 minus 3 into 5 minus lambda. Okay, now open this bracket, we get equation is lambda cube minus 7 lambda square plus 36 is equal to 0. So required lambda values. It is not possible to factorization or take any common, is not possible. It's not possible to factorization this one. Now you put lambda is equal to plus or minus 1 plus or minus 2 plus or minus 3. Now better put lambda is equal to minus 2. Put lambda is equal to minus 2 cube minus 7 into minus lambda square plus 36 equal to 0, or and minus 8 and 4 minus 28 plus 36. Now this is a minus 36 plus 36 get cancel 0. Now this is a first root, lambda is equal to minus 2. This is correct. Now lambda is equal to minus 2 is a root by inspection. Now follow the synthetic division. Now by the synthetic division applying, now taking the coefficient of lambda, this lambda cube coefficient is 1, this lambda square is minus 7, lambda is not there means 0, and this is 36. Now you write like this, lambda cube is 1, lambda square is minus 7, and no lambda means 0, and plus 36. Okay, then lambda is equal to minus 2, take lambda minus 2. Now it is 1 as it is. Multiplication minus 2 into 1 minus 2 is a minus 9, minus 2 into minus 9 is a plus 18, and add it again 18, minus 2 into plus 18 minus 36, and it is a 0. Now therefore now this 1 minus 9 and 18 write in the equation form, lambda square minus 9 lambda plus 18 equal to 0. Now this one, factorization is a lambda minus 3 into lambda minus 6 equal to 0, or lambda is equal to 1 is 3 and lambda is equal to 6. This is a lambda one more minus 2. Now therefore lambda is equal to first root minus 2, second and third, 3 and 6. These are a eigenvalues. Okay, now find the eigenvectors. Now eigenvectors is Now system of equation is a minus lambda I into x equal to 0. So that means this one is 1 minus lambda 1 3 1 5 minus lambda 1 3 1 1 minus lambda. This is a minus lambda I into x. X means x, y, z equal to 0. 0 means null matrix. 0 0 0. That is a column matrix. This is equation number 1. Okay. Now, so case 1, case 2. Case 1 put lambda is equal to minus 2. Case 2 lambda is equal to 3. Case 3 lambda is equal to 6. Now case 1, first case 1 lambda is equal to minus 2 in equation number 1. Equation number 1, put lambda is equal to minus 2. Now get equations, 3 equations. The equations are 3x plus y plus 3z equal to 0, x plus 7y plus z equal to 0, and 3x plus y plus 3z equal to 0. Take any 2 equations. I'll take first 2 equations, and x upon cross multiplication these elements is a 1 minus 21 is a minus 20 equal to minus y by, and multiplication 3 into minus 3 is a 0. Z upon these 2 elements, 21 minus 1 is plus 20. Now is a 20 is a common, it is a 1, y equal to 0, z equal to 1. The first eigenvector is 1 0 1, or this is a column matrix 1 0 1, the first eigenvectors. Now second one, case 2. Case 2, lambda is equal to 3 in equation number 1. So put lambda is equal to 3 in equation number 1. We get again 3 equations. The equations are minus 2x plus y plus 3z equal to 0. The first one. Second one is x plus 2y plus z equal to 0. Third one, 3x plus y minus 2z equal to 0. We take these 2 equations. Okay. Now x upon y upon z upon. Now first one, x upon multiplication these numbers. X upon 1 minus 6 is a minus 5 minus y by plus minus plus. Okay, then y minus 2 upon minus minus 2 upon minus 3, again minus 5, and z upon these elements multiplication minus 2 minus 1, again minus 5. Okay, minus minus cancel. Now 5 minus 5 is a take common, x upon, so x upon 1 and minus minus cancel, but y is equal to minus 1 and z is equal to plus 1. Now second eigenvector is x2 is equal to 1 minus 1 1, or is a column matrix. Okay, now case 3. Case 3 is lambda is equal to 6 in equation number 1. Okay, now in this equation number 1, put lambda is equal to 6. So lambda is equal to 6. Now equations are minus 5x plus y plus 3z equal to 0, x minus y plus z equal to 0, 3x plus y minus 5z equal to 0. take any two equations. I'll take first two. Is x upon multiplication these elements 1 plus 4. Okay, 1 into 1 and minus 3 is a plus 4 minus y upon minus 5 minus 3 is a minus 8. So minus 8 z upon multiplication minus into minus plus 5 into minus 1 is a plus 4. Okay, now 4 minus is cancelled, 4 is a common. It is x upon 1, y upon 2, z upon 1. Now third eigenvector is 1, 2, 1 dash or column matrix 1, 2, 1. So x1, x2, x3 are a eigenvectors. This is required solution. Find the eigenvalues and eigenvectors. The square matrix is given 3 cross 3 minus 2, 2 minus 3, 2, 1 minus 6, minus 1 minus 2, 0. First you find eigenvalues, then after eigenvectors. Okay. Now the characteristic equation is determinant of a minus lambda I equal to 0. Take minus lambda diagonally is a minus 2 minus lambda, 2 minus 3, 2, 1 minus lambda, minus 6, minus 1, minus 2, 0 minus lambda. Okay, this is equal to 0. Now expanding this one, expanding minus 2 minus lambda into multiplication. Okay, so minus lambda into 1 minus lambda and minus of minus, again it is a minus, is a 12. Plus minus plus, okay, minus 2 multiplication minus 2 lambda this element and minus of minus, again 3 times minus, minus 6 and plus, but minus 3 is there, right, minus 3. Okay, so multiplication these elements and it is a 4 minus 4 minus of minus plus plus 1 minus lambda. Simplify this one, so we get the equation is lambda plus 3 into lambda minus 2 lambda minus 15 equal to 0, or lambda plus 3 into, again factorization, lambda plus 3 into lambda minus 5 equal to 0. Therefore lambda value is equal to 1 lambda is equal to minus 3, again second lambda is equal to minus 3 again, and lambda is equal to plus 5. Two roots are same, third one is a different. First and two roots are same. These are a eigenvalues. Eigenvalues. Now the system of equation is a minus lambda I into x equal to 0. Okay, now a minus lambda I means is a matrix minus 2 minus lambda, 2 minus 3, 2, 1 minus lambda, minus 6, minus 1, minus 2 and minus lambda. A minus lambda I into x, x means x, y, z equal to 0 matrix, null matrix. Okay, now case 1, case 2, case 3, put lambda is equal to 3, case 1. So this is equation number 1. Case 1, lambda is equal to minus 3 in equation number 1. Okay, Put lambda is equal to minus 3. We get 3 equations. First one is x plus 2y minus 3z equal to 0, and 2x plus 4y minus 6z equal to 0, minus x plus 2y plus 3z equal to 0. Take any two pair of equation using the rule of cross multiplication, but in this case we have lambda is equal to minus 3, same root. Okay, now using the rule of cross multiplication we get x, y, z is equal to 0. Now important point, in case the rule of cross multiplication is applied, we get x is equal to 0 and y equal to 0 and z is equal to 0. Means it is x, y, z values are 0. Is a trivial solution. We get 0. So that time we take two variables. Variables can be chosen arbitrarily. So two variables, because two roots are same, so two variables are take arbitrary. First one is you take z is a k1 and y is equal to k2. So put z and y, take any suitable equation, take any one. Vector is, take x, y, z values. X is equal to 3k1 minus 2k2 and y is a k2 only, and z is equal to k1 dash, column matrix. Okay, now two arbitrary function, because the two lambda values are same, lambda 1, lambda 2, these two values are same, we get only one eigenvectors. Then direct go to the third, lambda 3, not necessary the lambda 2, we get same answer, direct go to the lambda is equal to 5. Case 2 is lambda is equal to 5 in equation number 1. Equation number 1 means this equation, put lambda is equal to 5 and put lambda is equal to 5 and multiply first equation, second equation, third equation. Okay, now we get three equations. The equations are minus 7x plus 2y minus 3z equal to 0, 2x minus 4y minus 6z equal to 0, minus x minus 2y minus 5z equal to 0. Okay, now take any two equations, take first two. Now x upon multiplication, these numbers, it is a minus 12 and a minus 12, minus y by, so plus minus plus as it is, okay, like this, y minus 7 to minus 6 is 42, then minus sign, 2 into minus 3 minus 6 means plus 6, z upon elements 28 minus 4, see plus minus plus like this. Okay, now x upon minus 24 minus y by is a 48, z upon is a 24. Okay, now take minus 24 common, so x upon, take minus 24, this is plus, y upon, this is minus 48, means again it is plus 2, z upon minus 24, this is a minus 1. Now eigenvector is x2 is equal to 1, 2, minus 1. This is second eigenvectors.